Okay, so this is the tutorial video for the first step of target D. So we're going to start with the SNAR of a dinitrofluorobenzene. So I'm just going to start. I've already weighed out my solid ingredients. So I'm going to pop them in a round bottom flask with the stirrer bar in there and add the solvent, which is THF in this case. And I can get that stirring. And then I'm just going to add my fluorobenzene, which is a liquid in this case, so I'm going to use a syringe. And that can now be stirred at room temperature until the reaction has gone to completion. Okay, so the reaction's been stirring for a few hours now, so I can remove the stirrer bar. Transfer this to a separating funnel. And now I'm going to extract this with water first, and then saturated sodium carbonate solution. So what you will find is, as you add the water to the solution, you will need to add a small amount of ethyl acetate in order to get two layers to appear, as THF and water are miscible with each other. So once I add the ethyl acetate, I should be able to shake it and see two layers forming. So as you can see, I've got two layers forming there now. So I'm going to extract the organic layer again with water once more, and then saturated sodium carbonate solution. I can then take the organic fractions, dry those with magnesium sulfate, and rotary evaporate them to afford the crude product. Okay, cool. So this is the hydrogenation step for target D now. So we've got our SNAR product from the reaction before. And I'm going to start just by dissolving this in methanol. So 50 ml of methanol, because I did this on a 5 millimole scale. And a stirrer bar in there. And I can just add the palladium on carbon straight into this mixture. So this is a 10% by weight, so 250 milligrams in this case. Seal this with a super seal, and then we can purge this reaction with nitrogen before we add the hydrogen balloon. Okay, so I'm now going to purge this system with nitrogen. So you can see I've already got an outlet needle in there. I'm going to attach a long needle connected to a balloon filled with nitrogen into the top. And you should be able to see a steady stream of bubbles through the solution. And I'll repeat this 2 or 3 times with filled balloons of nitrogen, just to remove any oxygen from the system. Okay, so I've purged this system now. I've replaced the balloon a couple of times to completely purge the system of oxygen. So this is all nitrogen in there now. And now I'm going to swap to a balloon filled with hydrogen instead. And I'm going to continue to bubble the hydrogen through, and I'll refill the hydrogen balloon once that is empty as well. The reaction's been stirring under an atmosphere of hydrogen for a few hours now at room temperature, and I've changed this. This is now a balloon of nitrogen, which we're bubbling through the solution with an outlet in the top of the flask to displace all of the hydrogen with nitrogen again before we do the filtrations. So that's been bubbling through for about 2 balloons now. So I'm going to remove the needles and unstop the flask. So I'm going to start by forming a sea-like plug which I can filter my solution through. So to do that, I'm going to spoon in a few spoonfuls of sea-light. And I'm going to make a slurry with methanol, much like you would with silica when you're prepping a column. And then I can apply some suction just to pack this down into a nice pad. When I make a sea-like plug, I tend to like to pack down the sides, as this helps to stop some of the palladium leaching down the sides. Okay, so my sea-like plug ready to go. I can take the septum out of this flask, and I'm going to gently apply this to the top of the sea-like plug. I sometimes find it useful to run it down a cylindrical, like a glass rod or something, and this helps to stop it from disturbing the sea-light at the top. And I can just rinse this flask out with some additional methanol. As I apply suction, I'm going to try and not let the palladium top layer dry out completely. And then I'm going to apply a layer of sand to the top, which I can keep wet before disposing of the whole layer in a specific palladium waste container. Once most of the colour has come through, that should be fine to now dispose of in a specific palladium waste container. And I can rotary evaporate this solution down to continue with the next step in the cyclization reaction. Okay, so I've rotary evaporated down the filtrate to afford a brown oil from the crude product, and to complete the cyclization step, I'm just going to redissolve this in a mixture of ethanol and some acetic acid, and then reflux this for 1 hour. Okay, so I've redissolved the sample in ethanol and acetic acid, attached a reflux condenser, and I'm just going to heat this at 80 for 1 hour until the reaction is complete. Okay, so the reaction's been stirring for an hour now, so I'm just going to cool it down to room temperature and rotary evaporate the solvent off to afford the final crude product, which can be recrystallized. Okay, so I can now purify the residue by recrystallization from acetone and diethyl ether in this case. So I'm going to start by taking my acetone and just dissolving this in a small amount, and I'm going to heat this up to get it completely dissolved in that. So once that is completely dissolved in the acetone, hot acetone in this case, I can slowly add diethyl ether. You should be able to see a precipitate already forming there in the solution. Once I heat this up, the solid will all redissolve, and as I cool this down, I can filter off the purified product, which should be a brown solid in this case. As you can see, after the filtration, we've got a dark brown solid, which is the purified product D.